Okay, so we'll be covering 1.5 linear equations, functions, zeros, and applications. I gave this to you on Monday, so you should have that, and I'm also going to send you a link just in case you don't. So you probably want to, if you don't have it, print it out, make sure you have it in front of you, and just kind of do it like we do it in class, and uh, take the notes as I'm talking about it or working on it. So with that said, I'm going to go ahead and jump into it. So the first thing that tells you there's a simple interest formula, which is interest equals principal times the rate times the time. We're going to use that on the first example. So I'm just going to read it. I'm not going to write it because you have it right there in front of you. So Demarion's two student loans total 28,000. One loan is at a 5% simple interest, and the other is at a 3% simple interest. After 1 year, Demarion owes 1,040 in interest. What is the amount of each loan? So there's two deals here, but we're gonna go take it statement by statement. That's how you gotta approach these word problems. So the challenge is going from the words to an equation. So from the first sentence, it says Demarion, two student loans total 28,000. Well, I don't know how much either of those loans are. So we'll call X one loan, and Y is the principal on the other loan. Okay, so this is like principal one, that would be like principal two, and that totals to 28,000. Okay, so that's all I get from the first step. The two loans add up to 28,000 from the first statement. And then from the second statement, I know that one loan is at a 5% simple interest, and the other is at a 3% simple interest. So there's two. We're gonna have to use this formula twice. There's two interests. One is the interest from loan X, and loan X has a 5% interest rate. So I don't know how much the principal is. So it's P times the rate of that first loan is 0.05, and it tells you after 1 year. So that time is 1. The interest for loan 2, well, the principal on loan 2 is the other one. That's Y times 0.03. And this was after 1 year as well. So you have interest 1, you have interest 2, and if we keep reading, the next statement says one loan's at 5% simple interest, the other loan's at 3% simple interest. That's where these two come from. After 1 year, Demarion owes $1,040 in interest. So in other words, this is the interest after 1 year for the first investment, plus the interest after 1 year for the second investment. So in reality, that's supposed to add up to 1040 according to that statement. But we also know that interest 1 is 0.05x, plus interest 2 is 0.03y, and that's supposed to equal 1040. Now, so we have two equations with x and y. The idea here is to solve for one of them. So I'm going to subtract x from here. I'll solve for y. You can also solve for x if you wanted to. And then I'm going to use this, and I'm going to put it in here. So the way that's going to look is going to be 0.05x plus 0.03 times 28,000 minus x equals to 1,040. So now what you'll notice is because I substituted this part in for y, on the next line there's no more, there is no y. There's only x's, which is good because we can solve for x. So we're going to have to multiply this here. We'll end up with 0.05x plus 0.03 times 2,800. That's going to be, let's see, 280. Should be 1040. I think. Okay, so I used the calculator on that, and that's actually 840. 0.03 times negative x is negative 0.03x equals to 1040, subtract 840 from both sides, and then I could also, well, we'll do one thing at a time. 0.05x minus 0.03x, subtract 840 from 1040, you get 200 over here. Combine these like terms, you get 0.02x equals 200. And then your final step is just divide the 200 by 0.02. Then you end up with 10,000. So X is 10,000. In other words, the investment for one of the investments is 10,000. So that means that the other investment you can go back and plug into this formula here. It's 28,000 minus 10,000, which is obviously 18,000. So investment Y was 18,000. Investment X was 10,000. So that answers that question. So with a lot of these, if you think back what we did, we kind of looked at each statement and we tried to see if there was any equation or anything that we can build from each verbal statement. So that's the challenge in these word problems, is try to get from the words to the math. But with the MyMathLab, they should kind of guide you through that. Hopefully this kind of clarifies it for this problem. But let's go ahead and try the next one, which is a similar thing on solar panels. Okay, so let's go ahead and read it. Solar panels in December 2009, a solar energy farm was completed at the Denver International Airport. More than 9,200 rectangular solar panels were installed. A solar panel converts sunlight into electricity. The length of the panel is 13.6 less than twice the width, and the perimeter is 207.4 inches. Find the length and the width of a panel. So first things first, if you can draw a picture, it would probably be a good idea to draw a picture. So we know solar panels on this problem are rectangular, as are most solar panels. And then it also tells us on the very last, or second to last sentence, it says the length of the panel is 13.6. So this is the length, 13.6 less than twice the width. So this is the width, and this says that 13.6 less than twice the width would mean that you take twice the width and subtract 13.6 from it. Okay, that's what that statement means. So now I kind of have, I've defined the length in terms of the width according to that sentence, and they also tell me that the perimeter is 207.4. But we also know that the perimeter, we have a formula for perimeter. The perimeter is basically two W's, the two widths plus two lengths. Right? But I know a couple of things. I know 207.4 is the perimeter. 2W is just 2W, but 2L is actually 2W minus 13.6. And so from here, I can, now you'll see that just kind of like in the last problem, I only had one variable, which is good because now I can solve for that variable. So if I just kind of work through this, I get 2W plus 4W, 2 times 13.6, that's 27.2. Combine your W's, you get 6W. I'm going to go ahead and add 27.2 here as well in one step. So that'll be 34.6 or 234.6. Or 0.6. And then the final step would be to just go ahead and divide that by 6. So which is what we'll do. Yeah, 39.1. So that's the width. Okay, but notice the question. You always want to look back and make sure you answer all the questions. So it says find the length and the width. So the width is 39.1. We have a formula for the length, so we can use this in this formula, and we're going to end up with 2 times 39.1 minus 13.6. And I would just put that into a calculator 2 times 39.1 minus 13.6. And you get 64.6 as your answer. Okay. And what you could always do is just check if it works. Does 2 times 64, 2 times 64.6 plus 2 times 39.1 add up to that perimeter that we're looking for, and on my calculator it sure does. So that works out. So that's another example. Again, we kind of look at word problems, and you look at the words and you create a math statement from that. Okay, so let's move on to the cab fare problem. On the cab fare problem, the Metro taxi charges a $2.50 pickup fee and $2 per mile traveled. So no matter what, you pay $2.50 and then an additional $2 per mile traveled. Grayson's cab fare from the airport to his hotel is $32.50. How many miles did he travel in his cab? So you want to create an equation that models the taxi charges. So no matter what, how much do you pay? Your cost will always be at least $2.50, right? Because no matter what, they're going to charge you to come pick you up in the first place. Plus, they're going to charge you $2 per mile. So we'll say X is number of miles. That's another important thing, is defining what your variables are, and at least knowing in the problem what the variables are. So a lot of times I'll do this. I'll just label that this represents cost. And I can see you can't see that yet. Here you go. That's cost, and that's number of miles. Okay. So we have an equation. Now they're saying that he already went to the airport, or to his hotel, from the airport to his hotel was $32.50. So that was the cost. And they want to know how many miles did he travel. There's a lot of ways to do this. I'm just going to show you the algebraic way. You can kind of guess and check it too, but let's do it this way. So $32.50 equals $2.50 plus 2x. Why did I put $32.50? Because that was the cost, and I'm interested in the number of miles with that cost. So you subtract $2.50 from both sides, and then you'll get it. Because you'll end up with 30 equals 2x, divide by 2, you get x equals 15. So that means that he traveled 15 miles in his cab. So he traveled 15 miles would be our answer. Okay, so that's the Metro taxi question. Again, you're getting a word problem. You're putting the words into equations. But let's move on from that. You'll also have a lot of examples in your notes as well, or your My Math Lab. Kind of utilize the question help and all that. But this takes some practice. But the more you get experience, the better. So zeros of function. So zeros are just intercepts. So in other words, and actually specifically x-intercepts. Okay, so I like to show y'all this at least one time, but zeros have many, you put zeros or has many meanings. You can call them zeros, you can call them roots, you can call them solutions. Okay, but all these mean the same thing. These are x-intercepts. That's what zeros are. And how do you find the x-intercept of a function? You set whatever function it is equal to 0. Okay, so for example, you have the function that's on your paper, which is f of x equals 5x minus 9. How are you going to find the 0 of this? We'll set the function equal to 0. Okay, and then you just solve, right? How do you solve this? You got to add 9, and then you just divide by 5. So there's your 0. Okay, and that's pretty much all there is to finding zeros. But with that said, that completes 1.5. I'm going to go ahead and jump into 6.1 here, which on 6.1 you have what we call systems of equations. Okay, so what I'm going to do is take you through the various methods of solving systems of equations through these examples. So let's just start with the first one. And depending on the problem, certain methods lend itself to solving that problem easier than other methods. Okay, so here what I will highlight is, and we might do a couple of them actually, solve the systems graphically. You know what, this one's a good one to do pretty much all of them. But no, we'll save it, yeah, because I have examples there. So this one we're going to do what it says. We're going to do it graphically. Okay, so I can't graph this the way it looks yet. So I want to solve for y for each of these. So move the x over. You're going to get negative y. Let me change the color here. When you move the x over, you'll get negative y equals 5 minus x. And then if you divide by negative 1, you'll get y equals negative 5 plus x. So that's my equation here. This one's a little easier. Just subtract 2x equals 1 minus 2x. So now I put it in slope-intercept form, meaning I can graph these. So I'm going to go to negative 5. Then I'm going to go up 1 over 1. So I'm going to put a point here, up 1 over 1. And then that's my line. Then this one is 1 minus 2x, so put a point here and down 2 over 1, and then I'll have, then you'll notice if I go down 2 over 1 again, I'll actually get a point on that, which is kind of what I'm looking for, because the solution to two systems of equations, the solutions to two equations will be the intersection. So that's the solution. Okay? So whatever that coordinate is, which from the graph I can kind of see it's 2, negative 3. Okay? That's how you find solutions graphically. Now you could also put these into your calculator. If you put this into y1, then you put this into y2, you could push second, I'm going to have to peek at mine real quick. It should be second trace calculate, or number 5, second trace intersect. So after you put your equations in to y1 and y2, if you push second trace, then it's number 5, which says intersect. Okay, and then you could just push enter, enter, enter. Enter 3 times. And then it'll calculate that for you. But this is how I might ask you to do it on a free response. So make sure you understand how to do that too. Now, additionally, the same question's on the follow-up one. It says you now do the same question doing substitution method. Okay, so what's this substitution method? I'm gonna start the same way. In fact, we kind of already did this on the last problem, on the last section. The idea is solve for one of the variables. So if you look at these 4, which one's easiest to solve? Probably I can solve for x pretty easily, and I can probably solve for this y pretty easily. So I'll just choose to solve for the x, okay? So x, I'm going to have to add y to 5. So it's 5 plus y. And then now that I have x equals 5 plus y, I'm gonna substitute 2 times 5 plus y. Plus y equals 1. So it's 10 plus 2y plus y equals 1. That's going to add up to 3y. And then subtract 10. you'll get -9, and then divide by 3, you'll get -3. And then so now that we have y equals -3, I can go ahead and put this to solve for x into that one. So that would be x equals 5 plus -3, which tells me that's going to be 2. And guess what? That's going to be a coordinate. That's my solution. And I told you it just so happens to be that that's the intersection. So again, the solution to these are intersections between the two graphs of these. Okay, so this method we call solving by graphing, and then this method we call solving by substitution. Okay, and the following question is slightly different, but I'd like to take the chance here because this is a good question because I can show you all of the methods. Okay, so I'm going to squeeze it in right here, and I'm going to squeeze in elimination here. Okay, so this is the method of using elimination. Now, on this method, what you would do is you're trying to, you can actually add equations, okay, or subtract equations, and even multiply equations, and even divide equations. But right here it's set up nicely because if I look at these y's, these are opposites. So if I add these two equations, right, x plus 2x, you're going to get 3x. Negative y plus y, that cancels out, right? So that's 0, so that's eliminated, right? So the variable is eliminated. 5 plus 1, that's 6. Divide by 3, you get x equals 2. And then you do the same thing as before. You're going to plug this into one of these equations. So 2 minus y equals 5. Subtract 2 from both sides, you get 3. And then divide by -1, you get -3. So you get the same coordinate. So those are the three methods. That's pretty much the lesson. The rest of it, we're just going to kind of practice this with some variation to some of these. So stay tuned. So that kind of shows you all three methods with the same problem. Okay. All right. So let's try the next example. Okay. So on this one's going to be just more practice. I'm going to kind of run through it here. 2x plus y equals 2, and x minus y equals 7. If I just add these together, you'll see kind of the same thing happens as before. The y's cancel out, you get 3x equals 9, x equals 3, and you can just plug in the x here. So I can plug it into, substitute it into either one. So 2 times 3 plus y equals 2. That's going to be 6. Subtract 6 from here. That's -4. So my coordinate, or my intersection, or my solution, is 3, -4. Now here's a note. You could always, anytime you have a solution, you can always check, in fact, if it is a solution. 2 times 3 is 6. Plus -4 is 2, so that works. 3 minus -4, minus negative turns to plus 4, so that's 3 plus 4, which is 7. So that works. So that's how you can check. Okay, so let's move on to example 4 here, which example 4, you'll notice, is slightly different. Because I can try to add them, but they don't necessarily cancel out if I add them, right? So how do I deal with that? And you know, actually, now that I'm looking at this, it might be a little bit better if we do the next example. We'll come back to this one because that's actually an extra step than what the following one would be. So meaning, let me do example 5. A. Okay. we'll even do B, but we'll start with A. So here, we're going to do this with elimination, but you'll notice the same thing I said earlier, it's not going to be able to cancel out. So we want to try and make it to where something matches, or at least they're opposites. So what I can do here is I can multiply equations by a number. So I'm going to choose to multiply it by 2. Why 2? Because if I multiply the x by 2, that's going to be a positive 2x, and then that'll be a negative 2x. And then if I do that, and I got to notice I'm going to multiply all these by 2, and then I'm just going to copy the other one underneath here. Nothing changed about that. And then I'm just going to add them. Because now you'll see what happens again is those eliminated. But why? Because I chose to multiply this by 2 because that's a negative 2. That gave me the positive 2x. That canceled out. But this one, okay, this one happens to be, that also cancels out, which is 7. Okay, so this one's kind of a unique question. What you got to ask yourself is, does 0 equal 7? Obviously not. So in fact, this is a special question that has no solution. Okay, anytime you see this. But there's this other side lesson here that I wanted to show you. But I think, let's try B as well. And we'll do that too. But you know what? A similar thing's going to happen to B. But let me just kind of illustrate. If maybe you're still wondering about this. So actually, why don't take a step further. What if I solve these for their graphs? So I'm going to subtract x from here, and then divide by negative 3. So that would be, divide that, and that would be positive 1 over 3x. So you'll get that graph. And then I'll do the same thing here. Add 2x, so you end up with 6y equals 5 plus 2x, and then divide by 6. But if you divide by 6 and you reduce, you actually end up with 1 over 3. And then what do you notice about these two equations? They have the same slope. And if they have the same slope, that means they're parallel. And if they're parallel, that means, are they ever going to intersect? No. So that's why this has no solution. But you can tell that from whenever the variables cancel out and you get something that's not true. Okay, as opposed to B on example 5, where you have something like this, and we're going to try to do the same idea, okay, as we did here. But if I want to try to get the 2 to match up to the 4, I can multiply it by 2, right? And I usually like to write it off to the side, so, but you know what, it's not a big deal. I usually like to write off to the side to just organize my work, but for this one, I'm just going to write it underneath. So this is going to be negative 4x minus 6y equals negative 12, and then I'm going to copy this one right underneath that. Okay, and then you're going to notice, hey, it's kind of like what we saw earlier. That's 0, that's 0, and then even that equals 0, but it's slightly different. Okay, so if you get 0 equals to some number, that's no solution. But if you get 0 equals to 0, what does that mean? Well, we could take. Well, I'll just tell you, and then we'll talk about it. It means infinite solutions. Okay, and then you'd be done. Okay, but I'm going to take it a step further. But what if we did the same thing? Subtract 2x, solve for y, divide by 3. Okay, and then solve this one, subtract 4x, and then divide by 6. And now it would be 4 over 6, which reduces to 2 over 3. And what do you notice? Well, this is exactly the same as this. So in other words, this line goes at 2, and then you go down 2 over 3, there's the equation. I'm going to set up. Starts at 2, go down 2 over 3. Okay, and there's your equation. And then you have this other line, right? So that's this line, and then you have this other line that also does the same exact thing. So then they're basically the same line. Or they're two lines, but they intersect at how many points? Infinite points. Okay? And you can tell that if you ever get a solution like this. Okay? So 0 over 0. Okay, so now back to the question we skipped, which I still didn't really get. Well, I did kind of show the point, but I didn't get a, one that's exactly like that. But maybe I can come up with one. But here. So here, yeah, I'll do that. I'm gonna put in, if you want to, you can put in the space on 4, maybe to the right. But let's come up with x plus y equals, or x plus 3y. You know what? I'm just gonna put up some random ones to get you some ugly answers. In fact, let's make this 2. And let's make this 6x minus 5y equals to 15. Okay, all right, this will be a good one. So I want to solve for something like this. This is my extra one. To kind of further illustrate that point, you want to multiply this by something so that you match this up to the 6. I could try the y's, but the 3 and the 5, I don't think I'm going to get anything. I'm not going to get a nice number to multiply 3 to get to 5. So I'm going to stick with the 2 to the 6. So I got to multiply by 3. But then again, I want this to be actually opposite. So probably negative 3 would be best. And I'm going to get negative 6x. Multiply that by negative 3. That's negative 9y. Then that's negative 30 over. I'm just going to copy the bottom underneath here. That cancels. That's going to give me negative 14y. And then that's going to give me negative 15. Then I just divide. I'm going to get 15 over 14. That's my solution for y. And then if I use this into one of the equations, I'll get my solution for x. So I'll just use the top equation. 3 times 15 over 14 equals 10, which is really 45 over 14 equals 10. I'm probably going to want this to be common denominators with that, so I should multiply this by 14 over 14, and that'll give me 140 over 14. So subtract 140 over 14, subtract that from 45 over 14. And that's going to give me 95 over 14. I can divide by 2, but you could also think of it as multiplying by half. So if I multiply both sides by half, that cancels out. And then this will be x equals 95 over 28. 95 over 28. And then from there, they have no common factors. So that would be your solution. So your coordinates would be 15 over 14 and 95 over 28. Okay, but I wanted to show one where it didn't have no solutions or infinite solutions, but you had to do that little skill there. So now let's move up to the next skill, which is something like this. Okay, let me scoot this over because I know I'm going to need the space. Okay, so you'll notice there's nothing I can multiply 4 by so that I can get 5, and there's nothing I can multiply 3 by, so I can get 2. So, or 2 to get 3 either. So I could multiply both equations. That's an option. So the easy thing would be multiply 4 by this one, okay? And then or really the whole thing. So that's going to give me 20x plus 15y equals 55. And then I could multiply this one by that number, 4. Just making sure that the results should be opposites. So this is going to be 4 times negative 5, so that's negative 20x, which is what I want. And then 4 times 2 is 8y. 4 times 15 is 60. Okay. Then you have what you want. You're going to get some cancellation or some elimination is what the method's called. That cancels. 15 plus 8y is 23y. 55 plus 60 is going to be 115. Divide that by 23y, you're going to get 5. Okay, and then you're going to plug the 5 in for either one of the equations. The top one looks easier, so I'll do that. Plus 3 times 5 equals 11. So that's 4x plus 15 equals 11. Subtract 15, you get negative 4, and then divide, you get negative 1, so your coordinate is negative 1, 5. Okay, and that's how you do it using elimination, where you have to multiply both equations by a certain number. Okay, so then we're going to jump into the final question, which is example 6, and that's an application to problems like these. So that one's a snack mixture problem. We'll just go ahead and read it. At Max's Munchies, caramel corn is worth $2.50 per pound and is mixed with honey roasted mixed nuts worth $7.50 per pound in order to get a 20-pound mixture worth $4.50 per pound. So how much of each snack is used? Well, there's some unknowns, and I'm just going to call X the first mixture, which is the honey roasted nuts. Oh, the caramel corn. Yeah, so we'll call this the pounds of caramel corn. And we'll call Y the pounds of mixed honey roasted nuts, or we'll just call it mixed nuts. Okay, so that's first defining our variables. And then they also tell us it's a 20-pound bag. So in fact, X plus Y should be 20 from that statement. Okay, so we have a 20-pound bag, and that's worth $4.50 per pound. The other thing we want to take a note says caramel corns worth $2.50, okay, per pound. So I can make an equation: 250x, 250 per pound of caramel plus 750 per pound of honey roasted nuts. And really what we want is a mixture, a 20-pound mixture that adds up to $4.50 per pound. Okay. So if I think about that, if it's supposed to be $4.50 per pound and it's 20 pounds, I really want it to add up to $4.50 times 20. Okay, so this is what I gather from these statements. So now that we got that out of the way, we can start to solve with some of the methods that we've been talking about, right? Also utilizing our calculator. So I'm going to start with doing the 450 times 20, which that's going to be 90. And then I'm also going to use, now that I simplified that, I'm going to use substitution. And it seems to be the easiest method here. So I'm going to subtract x. This would be y equals 20 minus x. Then I'm going to put this in for y. So we'll end up with 250x plus 750 times 20 minus x equals to 90. Then just do our solving. You'll notice again, we only have one variable, which is good because we can solve for one variable. Just doing 750 times 20, that's going to be 150 minus 750x equals to 90. 250 minus 750, that's going to be negative $5, or negative 5x, I should say. Then subtract 150, that's going to be negative 60. Divide by negative 5, you're going to get 12. So x equals 12. And so I know that there's going to be 12 pounds of caramel, but I'm also going to need the number of pounds of mixed nuts. So I have this equation, 20 minus 12, and that'll tell us that there's going to be 8 pounds of mixed nuts. And together those should average to 450. And again, you can always check these things. Is it in fact going to average to 450? You can do 250 times 12. Okay, and we'll see if we can do this in our head. That would be 250 times 12. That'd be 30. 750 times 8. That would be 60. 60 plus 30, that's 90. So these 20 pounds that add up to 90, which you divide 90 by 20, you're going to end up with 450. So it works out, and you can always check it that way. But again, the challenge of these word problems is getting from the words to the equations, and that's what you're going to need to practice. But that's it for today's lesson. You should have the notes there. Good luck, and I will see y'all next week. Take care.